protected by a recent act passed in Parliament, which is called Shanti Act 2025. We are having Atomic Energy Radiation Protection Rules 2004. We are having varieties of AERB safety codes, safety guides, and safety manuals. So these are the documents available, and we are following in medical applications also. For example, I will show you some of the safety codes which are used for the medical applications of radiation. As far as the role of radiation safety and AERB is concerned in our area, they always press this, their regulation is always categorized in two categories. It is called nuclear facility and radiation facility. Nuclear facility deals mainly with reactor related item, this fuel processing system, and front and back end related material safety, disposal. However, in case of radiation safety, all institutions dealing with medical application, industrial application, and research applications are coming. So as per AERB, our activity, that is medical application and research, falls under the category of radiation facilities. So whatever documents they publish for radiation facilities, all are applicable to us. So now first item for the radiation safety is the radiation protection standards. Now the question in mind could arise, what is the basis of radiation protection standard? For example, we follow nowadays ICRP 103 published in 2007. So why this protection standard has been prescribed, and what is the basis of this protection standard? So all protection standards, whatever has been designed and prescribed so far, mainly deals with these two items. Their approach is to prevent the deterministic effects and to reduce or minimize the probability of stochastic effects to a acceptable level. So these are the basis of all radiation protection standards, whatever we have seen so far. As far as AERV safety codes are concerned, we are currently having 3 safety codes for use in medical application like radiation therapy sources, equipment and installation. It is called MED SC1, the revised version of which. Excuse me, can you please mute your. Hello?
Yes, sir.
Okay.
Yeah, somebody is like
Arun and
Okay.
Sangram, you can
yes.
check the participant whoever mic is on, you can manually mute that. Yeah.
Anyway, no problem. Let it to go
Yeah.
on. So we are having varieties of radiation safety codes, particularly for medical application. We have 3 codes: one for radiation therapy, one for diagnostic X-ray, and one for nuclear medicine. And I hope you might have seen there is a general safety code published very recently by AERB, but applicability of general safety code is limited with the safety guides. Since safety guides has not yet been published, so still these safety codes are still in effect, and it will be in use till the new safety guides for radiotherapy, nuclear medicine, and diagnostic radiology will be published by AERB. So now the question is, what is the basic safety objectives, whether it is AERB or any national or international organization? They say that workers, public and patient, all 3 should be protected to the level they deserve protection. For example, for radiation worker, the dose limits are prescribed. Even for public, dose limits are prescribed. But the case of patient is a different criteria. In case of workers and public, they workers choose this occupation for their bread and butter. However, the public is not choosing the choice of getting exposed with the radiation. So their cases are different. However, patient is deliberately subjected to the radiation procedure either for the purpose of diagnosis or therapy. So this is categorized under the medical exposure where dose limits are not applicable. ALARA during normal operations of the practices is also followed by the user. It is not mandated by regulatory system. They can give a recommendation, but they do not enforce it. Then radiation exposure during normal operations shall be also within prescribed dose limit. I will tell you what are the dose limit, which is known to majority of us, but it is important for the our medical physics students. Potential exposures are the area which is a kind of probability, and the magnitude of this exposure and the time of occurrence of this exposure is not known to us. This is a probabilistic in nature. It can appear once in 1 million times, once in 1,000 times of operation of the equipment. So God only knows what about. But we should have some emergency plan and preparedness in our mind to minimize the exposure, magnitude of exposure arising from these potential exposures. For example, I will tell you the source is stuck up in a telecold machine. It is an example of a potential exposure. Even though we know from the design aspect that this can happen, but when it will happen, we do not predict exactly. Now, as I told you, we have to provide protection to three different types of the human being. Occupational exposure, where the person is opting for this occupation, and they know that they can be exposed to the radiation by some means, but their level has to be limited. Public exposure, they do not opt for it, but because of the activity conducted by some institution or the exposure required for diagnosis or therapy of their relatives can provide them some radiation exposure also. So this is also limited by the dose limitation. Medical exposure is opted by the patient deliberately for their better diagnosis, better therapy, and this medical exposure is not brought under the category of the dose limitation. For one information for the students, medical exposures are not categorized under dose limitation. The reason is the regulatory system does not know what will be the amount of radiation exposure to get a good diagnosis or good therapy. It will be the decision of a medical professional. So accordingly, regulatory system cannot enforce anything here. However, in case of diagnostic radiology, medical exposures are guided or limited by diagnostic reference level. You might have heard about DRL or diagnostic guidance level, DGL. So usually it is the responsibility of the research group or professional societies to work out on a larger extent in the country, generate the trend of the medical exposure in a given diagnostic procedure and prescribe the somewhat a average value so that others should also follow to limit the exposure to the patient. But medical exposures are not limited by dose levels. They are just guided by diagnostic reference levels. One more thing I wanted to specify here. When a occupational person becomes a patient and then they undergo exposure because of their sickness, the exposure given to the person is not coming as a occupational exposure, so it shall not be counted. So make sure that if occupational workers become sick, the badges shall not be taken to the room where the diagnostic exercise is conducted over the person. So as I told you, this exposure to the public and the patient and the occupational worker are limited by three different approaches. These are called nodal principles of the radiation safety. Justification of practice, it is generally applicable for medical exposure. Optimization of protection, it is also applicable for occupational worker, public as well as medical exposure. Dose limitation, it is applicable for public and occupational exposures only, but not for the medical exposure. And always these limits are prescribed by regulatory system. So for example, here AERB, almost in line with ICRU or ICRP, they have prescribed the dose limits for the different areas of the body. For example, whole body effective dose shall not exceed on an average 20 millisievert in a year. for 5 years, and it shall not exceed 100 millisievert in 5 years, with the exception that it can go up to 30 millisievert in a year. For example, we ask always a question here in RSO examination that if a person has got exposure for 3 years, for example, 20 millisievert, 20 and third 25 millisievert, what would be the dose limit for the person for remaining 2 years? So you can prepare yourself because these are all based on the dose limitation provided by the AERB. Now the question is, when ICRP has prescribed 30 millisievert in any single year of a 5 years block, why AERB has opted for 30 millisievert? The reason we have in our hand, for example, we understand that if the exposure received in a year is 50 millisievert, it gives some indication about the practice of the institution. So bringing down from 50 millisievert to 20 millisievert will be a difficult exercise. It may inculcate or it may cause heavy expenditure for meeting this requirement. So accordingly, it was thought to bring down to 30 millisievert, though this number seems to be a highly conservative or more strict, but it is a flexible number in comparison to ICRP recommendation. Similarly, for length of eye, for occupational exposure, it shall not exceed 150 millisievert in a year and 15 millisievert in a year for the public. ICRP has also prescribed 20 millisievert for the occupational, but so far our country has not accepted that recommendation. So these dose limits needs to be enforced and followed in our all the practices wherever it is applicable. Make sure once again these limits are applicable for public and occupational exposure only, not for medical exposure. As far as regulatory enforcements are concerned, we always look for two components. That is whether we can limit the exposure to the public and worker as also to the patient by means of providing built-in safety arrangements, and something if we combine through operational safety requirements, probably it will give you the good result. So accordingly, built-in safety requirements are prescribed for designing and making the sealed sources, because we have prescribed the standards for making a sealed source, whether it is a cobalt 60 telecobalt source or a brachytherapy source or any other source. Then also on the head shielding design of the radiotherapy equipment, for example, or radiology equipment. So standards are available here as well. And many times IEC standards or ISO standards are also accepted by regulatory system because it has got universal acceptability. As far as the other installation is concerned, AERB requires that the site should be selected in an appropriate manner. For example, the site should be probably in an isolated place where there should not be public occupancy, and usually it should be maybe at the end of the whole facility, so that general public do not come without any reason to this area. And they have prescribed the shielding requirement, and they have also given some guidelines during construction. Finally, if we have to transport the radioactive material, transport packages of adequate design and category as required. For example, while transporting brachytherapy sources, we always deal with type A package, and while transporting telecobalt source, we deal with the type B package. So AERB has prescribed requirements for both type A and type B packages. So in my opinion, all the person who are appearing for RSO exam must have some good knowledge. What are these requirements? Some of the things probably I am having here. For example, I start with sealed source standards. So this is the telecobalt source made in BRC as well as outside. Here, this is the ACL source. You can see the design. Design aspects are almost same for both the sources. So this is the fabrication aspect. Our brief is following: activity loaded in the capsule, then it is cleaned. After that, building is done when we feel that adequate amount of radioactive material has been placed inside. Then afterwards, this telecoiled source is called doubly encapsulated source. The purpose of double encapsulation is limit the exposure from the beta emitted because the cobalt 60 is basically a beta emitting source, and gamma emission comes as a after effect of beta emission. So we do not want beta to expose the skin of the patient. Secondly, these betas are also capable of generating a low energy bremsstrahlung X-ray. So bremsstrahlung X-ray should also be absorbed in the capsule, or their strength should be minimized. For this purpose, a double encapsulation is done. The purpose of double encapsulation is also linked with the shelf life of the source. When we are providing double encapsulation, probably we are increasing the duration of the use of this sources. So then afterwards they are tested, and I hope you are aware that surface contamination of these sources shall not exceed 185 becquerel. So all these tests are done, and this is a transport package in which this source is transported, loaded at the manufacturer site and transported to the user site. So now, what is the type testing of sealed sources which has been prescribed by AERB? So it said it should be in normal conditions of transport, accidental conditions of transport. So one has to decide whether it is a brachytherapy source or teletherapy source. Then accordingly, whether it will be type A package or type B package. So all these requirements have been prescribed by AERB. I will not be discussing everything in detail here. For example, performance standard for a sealed source of this is for brachytherapy. So you can see here, it gives there are temperature related test, external pressure related test, impact from a falling object, vibration test, and puncture test. So regulatory systems gives you some numbering. For example, if a brachytherapy source needs to be used as a intracavitary source, what should be the minimum requirement from the point of view of withstanding the temperature, external pressure, impact of a falling object, vibration, and puncture? So these are given in their standards. For example, for teletherapy source, you can see, say this source should comply of the requirement of temperature 5, pressure 3, impact 5, vibration 2, and puncture 2. So accordingly, a nomenclature will be given like here, C53524. This means then if this is the numbering from the safety standards, then this source can be used for telecobalt source. If a source is used for interstitial and intracavitary, it should comply with the required temperature requirement of 5. Temperature requirement of 5 means it should withstand the temperature of minus 40 degrees Celsius of at least 20 minutes without making any change in its geometry or having leakage beyond the permissible level. And it should also withstand the higher temperature of about 600 degrees Celsius for 1 hour. So these are the requirements, for example. So accordingly, these sources are classified like this. So probably you might have seen in the source certificate that these numbers are quoted, type or class of the sources are quoted like this. Now, requirement for ideal requirement for brachytherapy, majority of all of us are aware. This is half-life should be optimum, not very, because long-lived sources pose a problem of disposal as well, because their useful life may be not so long. Then a specific activity shall be as higher as possible. Photon energy shall be optimum. So usually 400 to 500 KV energy is thought to be optimum, but we do not have this source all the time available. Decay scheme should be as simple as possible, and purely it should be either pure beta emitter or pure gamma emitter in this case. So these are the safety standards required for this sealed sources. Now, similarly for equipment, for example, we are having requirements for telecobalt source head. So this is the example of a built-in safety. So here you can see AERB prescribes the off condition leakage. You know, almost all of you are aware, and on condition leakage. This is basically prescribed by IEC. The booklet number is 60601-2-11, published in 1997 and then revised in 2004. So these number shall be in mind of all the candidates who are appearing for RSO examination. Similarly, for the head leakage of the accelerator, these requirements are prescribed. So this is the example of built-in safety. Requirements are prescribed for X-ray leakage, neutron leakage. So I hope majority of you are aware about these requirements. Similarly, for collimator transmission, in nutshell, I can tell you that the collimator transmission maximum value shall not exceed 2% when only one blade of a complete collimator system is used for defining the beam geometry. And if all the components of a collimator system, secondary collimator system is used, then total transmission shall not exceed 0.5%. So this is the method of measurement given by IEC, and it is used while measuring the leakage from the transmission from the collimator system. As far as the built-in safety requirement for the facility is required, so AERB requires that facility should be properly shielded. So I hope we all are aware that we have to work out the ball thicknesses depending on the workload from the equipment. So first we have to calculate the workload, which takes into account the number of patients taken in a week for a given approach, the dose delivered per patient, and the distance from the center of the ISO center of the machine, what is the occupancy around the facility, and what is the use factor. Use factor is important for both primary barrier thickness calculation as well as secondary barrier thickness calculation. So all these parameters, I hope all of you are aware, but our students should go through this, how to calculate the workload, how to know the use factor for a given condition. For example, use factor in case of accelerator, we take every primary ball as 1/4. But if I go to the brachytherapy facility, use factor becomes 1 because it is a panoramic exposure situation. So what I mean to say, the value of use factor depends on the type of the use. Here we are using a collimated beam. That's why use factor can be a fraction of 1. However, in case of brachytherapy, we are not using collimated system. That's why use factor is always 1, whether it is a primary beam or secondary beam. Now, in case of brachytherapy, this is the typical layout. As far as operational safety is concerned, we are having many parameters. First of all, we start with we should have a availability of the qualified and certified personnel like radiotherapy technologists, medical physicists, RSO. Depending on the nature, I am talking here about the radiotherapy. Workplace monitoring by means of zone monitors and survey meters. And when you carry out the area survey, always I have seen that people are taking this instantaneous dose rate as the value for giving the decision, but that is a wrong practice. Always go for calculating the time average dose rate, that is called TADR, and whatever value we get in terms of dose per week, from there you give your decision. What is the safety status of the facility, whether it is complying with regulatory requirement or it is not complying, and if it is not complying, what are the remedial actions. Similarly, personal monitoring is also conducted by means of TLD badges, either by BRC or by its accredited laboratory in the country. So I hope all of you are aware. Personal monitoring badges are a quarterly service, and if dose to a occupational worker exceeds more than 10 millisievert in a quarter, it is classified as a case of excessive exposure. And then further investigation are carried out by RSO and by taking input from the person as well. So one has to take care that these badges are kept in a good, kept in a place where there is no radiation when it is not in use, and it should be used by the person for whom it is, and it should not be used interchangeably by many staff of the institution. Then the facilities should be safe as well as security, particularly for isotopic system-based equipments are also important component. We should have all safety accessories for handling the unwanted scenario. For example, in case of telecold machine, we should have T-rod and we should have source pushing rod available in the control console. Preventive maintenance of the equipment is one of the important component for meeting the operational radiation safety requirements. So accordingly, AMC and CMC are provided to the equipment supplier. Interaction with regulatory body, as and when you feel that you are in some doubt and you are not able to take any decision what should be done in this particular case, then you are always free to call someone from the regulatory system or send an email. They will definitely like to respond to your queries. And last but not the least, all the facility must have a well thought emergency planning and preparedness. So this depends on the institution, what type of emergency planning and preparedness you should have. There are some typical procedures available with manufacturer, with regulatory system, but you should also give your own thought. What should be the possible emergency scenario and what should be the response aspect for this. So with this, I hope I am coming closer to the last item of my this talk. What should be the defense in depth? This term you might have heard in radiation safety very often. And it prescribes that if you are following the procedure of prevention, which can be done by means of incorporating the routine quality assurance program, for which AERB has also prescribed QA procedures, but not to your level. AERB says that QA shall be done, but it is the physics group which should decide what should be the QA, which should be done on daily basis, weekly basis, monthly basis, yearly basis. And if you have the good detection system, this means AERB requires that you should have all safety systems available to your equipment. And if you have a good response emergency plan and its preparedness, then we say that you are following the procedure of defense in depth, and probably it will either not allow to get unwanted exposure to somebody, or if by the way it happens, you are able to handle the situation in a very effective manner. So I think I have completed by this slide. So thank you very much the organizing team as well as the person who are attending this lecture. It was basically aimed for the medical physics students, but maybe some information might be useful for the working people as well. So thank you very much. If you have any question, I will definitely like to answer your query. And once again, thanks all of you. Thank you very much.
Thank you so much, sir. It's a very
Thanks.
insightful and very informing lecture, and it is reminding me, sir, like how we are going through this course and how we are used to sit from morning 9 to evening 6 o'clock, and it is like reminding everything. But sir, from our internship students, sir, there is a common one question is so how to prepare for RSO exam?
Yeah. Yes, it
So,
is a
sir,
very right. Please complete your question.
yes, sir. So the question is, sir, there are many subjects and all, but how
Mhm.
to collimate our preparation in a particular way so that right now the pattern has been changed also, like 90 MCQ, 10 mark subjective. So
Yes.
from your what you want to, sir, put some insights so that they will prepare not only our interns, our physicist community, those are
Yeah.
preparing, and the attempt is also very strict. So from that
Yeah.
point of view, please, sir, enlighten us.
Yes, sure. So actually, preparation, we always like to see, probably you will read many things in your textbook. So we like to see your understanding as a radiation safety professional. We do not like to test your memory power in RSO exam. If you are not remembering some number, probably it is not a negative component. But if you are not giving us a logical answer, probably it is thought to be a means under preparation. So in my opinion, we have prescribed a syllabus which contains some component of radiation physics. For example, as I told you, interaction of radiation with matter is a very important chapter which is useful throughout our career, starting from a student to this shielding design calculation to even interaction of radiation for clinical application, biological effects, everywhere it is used. So one should know what is the interaction of radiation of a given type and energy, starting from a 20 kV X-ray to 150 kV X-ray, gamma rays from cesium, cobalt 60, iridium, then X-rays, electron and proton, even neutron also, some component of neutron. So this is understanding based preparation here. Then something about detection, because we know that varieties of detectors are used for in our area, starting from gas field detector like ion chamber, proportional counter, GM counter, then varieties of solid state detectors like TLD, OSLD, MOSFET, diodes, and then we are having chemical detectors also like varieties of films we are using. For example, radiochromic film is very popularly used. Then we are using some of the chemical dosimeters by some of the groups, not very popularly in all the institution. So my idea would be, when you are preparing about detector, you should know its basic working principle and what is the type and size of detector suitable for a given application, and what is the limitation of this detector. Sometimes we say that whether we can use a zero point zero 0.05 cc ion chamber for measuring the output of a telecold machine or output of a X-ray from the accelerator. So usually answer should be no. The reason is not only the recommendation of different protocols. Also, once you come down to the very small volume of the detector, its sensitivity decreases drastically. So there will be fear of losing some radiation event caused by the primary or incoming radiation, so that it will not give you the correct information. So limited sensitivity of the detector is not a good choice for using this for our application. So such things, but at the same time, people will ask you, then why we are using for relative dosimetry? Because relative dosimetry is a ratio of the two radiation events and two different points. So if the detector is having a limitation of leaving some of the radiation events, be not able to detect everything, this is happening throughout. So if you are taking a ratio, probably that negative aspects has been nullified. Because of that, we go for a small volume detector, even though its sensitivity is limited. And in case of reference dosimetry, we hardly use this type of detector. Only those detectors which are fulfilling the requirements of the protocol should only be used. This is how detector radiation biology. You must study the stochastic and deterministic effect. Remember some dose values for this deterministic effects, and which is the organ system responsible for this deterministic effect. So this is the very good approach. And then coming to the regulatory aspects and radiation safety aspects, uh, here many a time we like, as I told you, we like to go for application a specific test of your understanding, not for just remembering whatever is written in your textbook. For example, we may not ask you to just tell what is the thickness of a typical thickness of teletherapy primary beam. Rather, we say that how we will calculate the workload for a telecold machine for working out the primary barrier thickness, for example. So this way, if one prepares, I hope it is a very good preparation, and score will also be good. One more approach I will like to tell you, in with negative marking system, nobody should try to get 100% a score. The reason is definitely somewhere you will be having some confusion in answer, then it will get you negative mark. That will pull you down from the qualifying marks for appearing in the next step. So my suggestion would be prepare well with understanding, not just by memorizing something, and make sure that you are acquiring at about 60 marks or 65 marks maximum. Do not to go for scoring 90 marks or 100 marks because you wanted to become topper of the exam. However, if you are so confident, definitely there is no doubt. But if you are in confusion, try to limit your answers in a manner that you are at least getting marks close to 60 or so. This is for objective question. For descriptive question, you should always, it is the test of your writing skill, not only the scientific component. So this was the intention of the chairman AERV to keep at least 10 marks descriptive test. And here they wanted to test your writing skill as well as your technical competence. So I think once it becomes descriptive, it is evaluation is also a kind of analog evaluation. It depends on the examiner, but more generally, examiners are human beings. They are always having sympathy to the students or the aspirants for RSO certification. So they take care of this component. So I hope this would have given you some information that how to prepare for RSO exam. Thank you very much.
Thank you, sir. Sir, last question. It is a common question because previously, like, sir, BRC is conducting 2 times in a year the RSO exam. So, what will be the like next RSO exam, tentative one? So,
it is
people like
now.
to-
It was decided last year. I have a good news also for all of our RSO aspirants that AERV has agreed to increase one more attempt with certain rider that will come in our announcement. So those who has finished 3 attempts, they will be given one more chances. So with that, some conditions, that condition we will spell out in our announcement. So this is one information. Secondly, we had a meeting with all concerned, including RPAD, AERV, and it was decided that we should not conduct this examination twice in a year. Reason I will tell you, say for example, if a candidate finishes his or her medical physics course in the age of 25 or 26 years, and if the candidate is so confident that they can take up RSO exam in 3 consecutive approaches, if the candidate clears, it is well and good. But if the candidate does not clears, by the age of 28, the candidate feels that my world is dark. So I do not have any option for becoming an RSO. So then it is a very long duration. If you like to work for a period of age of 60 years, you have to work without RSO certification for 32 more years. So this consideration was brought in the mind, and we will very specifically writing this time in our announcement that it is not mandatory or necessary to appear in consecutive RSO examination. You can appear this year, and if by the way, unfortunately, you do not get through, analyze yourself, take 1 more year, 2 more year to prepare yourself well, and appear in the 3rd year or 4th year from here, and make sure that now this is my last attempt from your side, and make sure that you are scoring good marks and getting through with the Viva. In particular, in Viva, I will tell you, we are not very much different. We ask what you are doing, and but we like to know, as I told you, like to know your understanding of the content, not just testing what you remember and what you do not remember. For example, many times we are asking what you are doing in the morning while working in a hospital. Many people say that they are doing the daily quality assurance test on the accelerator, on brachytherapy unit, on so and so unit. If we ask 1 or 2 questions from there, they are unable to give a reasonable answer, then probably it is thought to be a negative part. So my suggestion would be whatever you are doing, make sure there you are confidently be able to answer if any question arises from here. So RSO exam, this is the one suggestion. As far as RSO exam in a year is concerned, now onwards, it will be conducted only once in a year. Most likely in this year, maybe in the month of uh, maybe April end or May first week or so. Tentatively, I am taking about maybe 15 days here or there. It can happen. It can go later only. So most likely it will be started maybe sometime in the month of June from next year. So that only once in a year, and we will have this in our course calendar, whatever we are publishing for other short-term courses. So dates will be known to the candidate from 1 year ahead. So over to you, Mr. Pradhan.
Thank you so much, sir. Now, Sir Suresh, sir, I would like to request you to give vote of thanks for this valuable time and information. So, Suresh, sir, I hand it over to you.
Uh, sir, do you have 5 more minutes to take
Yeah.
2-3 more questions?
Yeah,
So
yeah,
there is,
you can,
yeah,
you can.
yeah. So there are two questions what I see in the chat box. One is this boron neutron capture therapy. You said that it is used for secondary cancer. The question is, why
Right.
is it so?
Yeah, reason I will tell you, because you wanted to kill cell by cell. So primary cancers are not thought to have, whatever clinical trial has been conducted so far, primary cancers are not thought to be a good candidate for this therapy. So because of that, whatever data we have available as of now, it is related to secondary cancer only. So this was my basis of bringing this information.
Okay. Thank you, sir. There is one more question. Is bubble chamber still in use in India?
Bubble chamber, bubble detector, not bubble
Yes,
chamber.
bubble detector. Yeah.
Bubble detector, yes. Our IG car, they are having a full-fledged facility of using bubble detector for neutron measurement. Even it was thought some time back that bubble detector could be given for personal monitoring also, but it has not happened so far as a replacement for CR39 based this neutron detectors.
Thank you, sir. There is one more question, sir. Someone is asking, what is your expert view on electron brachytherapy, IORT treatment?
Electronic brachytherapy.
Yeah,
It is,
electronic brachytherapy.
electronic brachytherapy. So yes, this is a good approach because it does not make use of the isotopic sources. So disposal and security of the sources is a are not concerned. But IORT systems, I hope the lifetime of the X-ray tube is very less. They cannot be used for many patients. So this is the limitation of the miniature X-ray sources. Otherwise, it is a good approach. Some limited clinical trial has been conducted and some publications are available on this.
Yeah. So I will just add on this IORT. Recently, there was a publication from Astro or ISRO. I exactly don't remember, but they have concluded that there is not much benefits of IORT, and the recommendation of the IORT should be at the discretion of the clinician, but has to be carefully guided. So
Right.
there was a precautionary note, and that is why you will say that the IORT was not much popularized.
Yeah, yeah,
Uh,
yes.
there is one more, sir. You have, since it is in your slide, that's why I'm asking this question. You have also spoken on that. What are the characteristics of isotope used in theranostics?
Theranostics, actually it should be carrier free. That is a requirement. Carrier free in nuclear medicine is a requirement, but it should have both beta emission as well as gamma emission. So, but more generally, you know that gamma emission is a after effect of beta emission only, but energy should be in the range which is required for medical application. So you have seen lutetium, which is a good theranostic radioisotope. Its beta energy is somewhere 2.5 MeV or so. and gamma energy is also close to 160 kV or so. So lower gamma energy for imaging and higher beta energy for therapy. So these are the two requirements we have for theranostic agents.
Yeah. So the most popular isotope is the lutetium, and ARB has already said that it can be done as an outpatient therapy. What we require is a room with an attached toilet, since it is a beta emitter. Second
Right.
isotope is yttrium 90, which is used for the liver metastasis (SCC). But it requires a gamma camera for pre-imaging to calculate the lung shunt. So these
Yes,
are the
yes.
two. Yeah. So since we have to respect the time, the session was for
No,
1
no
hour.
problem. I can see there are one or
Okay.
two questions you can ask.
Okay,
No
then
problem.
let's go ahead, sir. If you have that permission. So why IMRT factor is used for leakage radiation calculation and not for primary barrier calculation? That's a good question.
IMRT factor is used
Factor.
for leakage radiation.
Radiation calculation.
So I will tell you, primary ball, we are calculating the work load for IMRT system. So primary component is already taken care, but the accelerator is on for a longer duration, which is the component of secondary barrier only. So that's why leakage radiation is the factor which is needs to be considered for the calculation of a scattered ball thickness. That's why IMRT factor is used for leakage radiation only.
Okay. What are the possibilities of BNCT coming to India?
Yes, this is, I don't know whether anybody is going to buy a commercial system, but for your information, BARC is making a low power reactor, 40 kilowatt miniature reactor, which is which will be installed in Actrek, Navi Mumbai, Kharghar. It may take 2 to 3 years more, but this work is going on.
Uh, low power reactor. That's a good news, sir. So in this regard, I also have one more question, sir. This certain generators like gallium is a very popular generator nowadays for prostate diagnosis. So these all generators are manufactured out of India. Is there any possibility that it can be done in India, the manufacture of gallium?
Yes, some efforts are going on, but I'm not very sure whether it will come in near future, but something is going on to make indigenize almost all isotopes, whatever we are procuring. Some efforts are going on.
Great. So I think I don't see any more questions, sir. Okay, there is just now one question has been dropped. We have any specific document for proton therapy shielding calculation? There was one question on the proton therapy. Sangram has already replied that it will require altogether a different class. So do you want to speak one or two on this, sir, or we should take it to another class?
What is the question?
So the
Is there
question
any
was,
document for proton
so
therapy
the
calculation?
question was proton therapy shielding calculation, like, sir, what is the design,
Yes.
how we will calculate? So
Yeah.
I replied
Actually,
that it is a separate class. So
so
if you
don't
want to
worry,
say, sir,
actually, proton therapy shielding calculation, it is dominant by neutron. When you go for shielding calculation by proton, neutron production is a real problem. So you have to provide shielding. Manual calculation for proton is not yet designed because it very laborious activity. Only Monte Carlo based approach is used so far for shielding calculation of proton therapy facility, and mainly you need to shield the cyclotron room with adequate shielding as well as the treatment room. But now you might have heard that the compact proton therapy systems are also coming, which will be only one gantry system, and it will be requiring the space just like our a standard accelerator only, but ball thicknesses will be different. So the information I wanted to share is, as on today, empirical approach has not been adopted for shielding calculation in case of proton therapy. Only Monte Carlo based approach, and specifically MCNPX is the good Monte Carlo tool for this calculation.
Great, sir. Thank you. I have to take this question because this has been asked by Naveen, and I think Naveen was our guy just 1 year back. Has flash therapy been tested in human clinical trials yet? And if
Yes.
so, what are the outcomes?
Yes, actually very limited trial in Netherlands. They are having, I think, a specially designed accelerator. And they have done, so I think it is on 2 or 3 patients only. Their result is very encouraging, but there is a limitation as well. We are assuming that during flash treatment, the radioresistivity of the normal tissue increases because of the absorption of the oxygen. That is the hypothesis we are following, but they have found some questionable item also in this clinical trial. So, in my opinion, this flash therapy has been applied on the human being. It is being applied also because US has come out with a very high intensity electron irradiator. They are also using some clinical trial on some human being, but they have not come out with data. So in maybe in a year or so, we will have some data from the clinical trials on the human being, which will give the real information whether the mechanism, whatever we are expecting from biological point of view, it is working or it is not working, because there are some contradictory publications are also available for flash therapy.
Okay. So there is one more question, sir. Can we use cobalt treatment if the output falls below 50 centigrade per minute?
No, as per the requirement, no, because you are using high dose therapy here also. So it is not in the range of high dose therapy. Because of that, it is not advisable. This is not having regulatory requirement. It is radiobiological requirement.
Yeah. Yeah. So for you, you have to understand those 5 hours of radiotherapy, why
Yes.
this low dose therapy will not work. Okay.
There is question. Yes, you can read that question.
Okay. You said that only one time a year RSO exam will be conducted. What about number of passing rate, sir? Will it increase?
Passing rate, you will decide.
Yeah. So it's not a question for sir, it is question for you all, that how well you prepare. And sir has given enough hints that how you have to tackle the exam. Don't go for all. Okay, if you are not confident, then limit yourself to those passing marks where negative marks will not be impacting your the output of your results.
What is the typical thickness of primary barrier of proton? I have read the question. It is 4 meter.
Okay.
4 meter concrete.
4 meter concrete. So if we use any hydrogenated materials, okay.
Maybe because this concrete thought to contain moisture also. So hydrogenated materials are also, yes.
Okay. So I think, sir, this is the last question. So I will like to thank you again, sir, from bottom of my heart, that it was always a pleasure to listen to you, because your lectures are very crisp, clear, and at the same time grounded. That is what I saw in this presentation also, that you have tried to cover all the topics, but there was a clarity on each and every slide what you have given. And as I said, that your popularity is so much, sir, that we have already crossed almost 225 attendees. Though we have only shared this presentation that it will happen at maybe 7:30 p.m. in the evening yesterday, because that is what I got the creative from Sangram and Arun. So by the time we have now so many attendees, sir, thank you very much. We will like you to be again on this forum, so that it will benefit not only our interns, but our aim is that all the physicists who are available, those are our students, and we should be catering to them all. So thank you very
Sure,
much, sir.
sure. Yeah. Thank you.
Thank you so much, sir. Thank you so much, sir.
Thank you,
So,
all of you.
yeah.
Thanks very much.
So
Thank you, sir. Thank you.
all the participants, thank you too also. And in future there will be many more classes. So please do attend that. Thank you all. Bye.
Yeah, thank you.
Thank you very much. Thank you, sir. Thank you all for attending.
Thank you so much, sir.
Sir.